everyone, welcome to Code with Laya. Today I'm going to explain you the algorithm for bubble sort. Right? So this is the algorithm. First start and I've written repeat from I equals to 0 to n minus 1. So you have to use a for loop for this, and that for loop is for pauses. See, we have seen the working of bubble sort, right? For each comparison, okay? So for example, I've started my comparison at 0 and 1, now 1 and 2, 2 and 3. Okay, how many comparisons did I make? 4 comparisons in the first pause, right? After that, I went to the second pause, then the comparisons has reduced to 3, right? Each time when the pauses are increasing, comparisons are being increasing. Sorry, comparisons are being decreasing, right? So, I've took a loop. Okay, outer loop is for number of passes. For each pass, these many comparisons should be there, right? The second one is repeat from I equals to 0 to n minus I minus 1. What is this called? So, what did I say? Basing on the number of, passes, the comparisons are being reduced, right? So, on which basis? On outer loop I basis. So, that's the reason why I took it from j equals to 0 and it should happen till n minus I minus 1. When I equals to some specific value, that should be included here also. Okay, only then passes gets decreasing. Otherwise, if you don't do this and you will write it as 9 minus 1. Okay, so for example, in the first pass, you got an element, highest element in the last comparison. Okay, finally, you have moved it to the last position. Okay, we say for example, A of 4th position is the last position. You have moved it over there. In the second pass, should I include that sorted element again? No, I should not include. If I include that, no, it's already sorted. It's being, extra time consuming, right? Extra memory consuming. Okay, so that's the reason why I took n minus I minus 1. This is for passes and this is for comparisons. Comparisons reduces basing on passes, right? So, if these two conditions are true, if A of I is greater than if A of j is greater than A of j plus 1, that means you are comparing adjacent elements. A of j, so suppose it is j equals to 0. If j equals to 0, A of 0 is greater than A of 1. That means you are comparing two adjacent elements. I've already said that in bubble sort you cannot compare, A of first element, A of third element, or A of 0th element, A of second element, like that. You can only compare the adjacent elements, right? Now, in case if this condition is true, suppose A of 0 has 40 and A of 1 has 32. This condition is true. That means if you are trying to arrange in ascending order, all the least valued elements should be there in the low index. That means 0, 1, like that. But here 40 is placed at first position. So they has to get swapped. So you will interswap them like this. So in A of j position, you will write A of j plus 1. And in A of j plus 1 position, you will write A of j. Right? So you have to continue this process till the end of the array. And, first you have to finish the inner loop. Only when you when you get the inner loop false condition, you will go to the outer loop. First end the inner loop. Next end the outer loop. Last stop. Right? So this is how you perform the algorithm for bubble sort.